Hello students, welcome to the class. In this class, we are going to discuss about relatively prime numbers. After this class, you people are able to understand why we need to find GCD and what do you mean by relatively prime numbers. As we have mentioned, how you come to know, you will come to know why we need to find GCD means what. To study relatively prime numbers, one must know what is GCD. Yes, GCD, or you can call this as highest common factor. As I already mentioned, GCD is also called as highest common factor. So let us see what is the definition of relatively prime numbers. Okay. Two numbers are said to be relatively prime if they have no prime factors in common and their only common factor is 1. What do you mean by this? If you have a two numbers, we say those two numbers are relatively prime. If they don't have any common factors, if they have a common factor, that must be only 1. Meaning of that is this. Means what? Common factor means what? Common factor is nothing but GCD. As we know from the definition of GCD, common factor, this is a common factor. If those two numbers have their common factor as 1, then you can say those two numbers are relatively prime numbers. The relatively prime numbers are also called as co-primes. You can say two numbers A and B are relatively prime, or you can say A and B are co-primes. Both are same. Yes. So now let us see. We'll see this with example. Let us check. For example, let us check 4 and 13 are relatively prime. Relatively check this. As I said, to check this, we need to prove if they are relatively prime, their GCD must be 1. To find their GCD, you must find their divisors and common divisors. So let us check divisors of 4. So divisors of 4 are what? 1, 2 and then divisors of 13. Divisors of 13 are what? Divisors of 13 are 1 and 13. So now among these, what are the common divisors? So common divisors are among these 1, 2, 4, 1 and 13. Common divisor is only 1. Here 1, here. So it is only 1. So common divisor is 1. Then what it implies? GCD of 4 and 13. Since common divisor is only 1. So 1 itself is their GCD. That is the greatest common divisor. So GCD is 1. If GCD of any two number is 1, then you can say what it implies. Given two numbers 4 and 13 are relatively prime. So this is how to find the or check the whether given numbers are relatively prime or not. Or you can say 4 and 13 are co-prime. Yes. Let us check one more example. We'll check one more example. Now take 15 and 20. 15 and 21. Yes. Same procedure. Find the divisors. So divisors of 15. Divisors of 15 are what? 15 the divisors. So ಯಾವ್ಯಾವು 1, 3, 5 ಮತ್ತೆ 15. Next divisors of 21. 21 of the divisors ಯಾವ್ದು 21 divisor 1, 3, 7, 21. Now, among these two sets, we have to find common divisors. So, common divisors. ಯಾವ್ದು ಇಲ್ಲಿ ಕಾಮನ್ ಯಾವ್ದಿದೆ, ಇಲ್ಲಿ 1 ಇದೆ, ಇಲ್ಲಿ 1 ಇದೆ, ಇಲ್ಲೂ 3 ಇದೆ, ಇಲ್ಲೂ 3 ಇದೆ. ರಿಮೈನಿಂಗ್ you don't have any common terms. So 1 and 3 are common divisors. Among these two, which is the highest? Among these two, which is the highest? 3 is the highest. So greatest. So GCD of 15 and 21 is what? 3. So to say, we are checking whether given numbers are relatively prime or what. For that, GCD must be equal to 1, but our GCD is 3. So what it implies? Given numbers, what are 15 and 21 are not relatively, or you can say they are not co-primes. They are not relatively prime. Right? This is how for two simple examples, two simple numbers, you can find the GCD. This relatively prime or not, or co-prime or not. Suppose if you are given with some other bigger numbers, ಇದಕ್ಕಿನ್ನೂ ತುಂಬಾ ದೊಡ್ಡ ನಂಬರ್ ಕೊಟ್ರೆ ಅವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಯೂಶುವಲಿ GCD ಇಂದ ನಾವು ಯುಕ್ಲಿಡ್ಸ್ ಅಲ್ಗಾರಿದಮ್ ಯೂಸ್ ಮಾಡಿ ಮಾಡ್ತಿದ್ವಿ. ನಾವು ಇವಾಗ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಅಥವಾ ಕೋ ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಅನ್ನು ಹೇಗೆ ಯುಕ್ಲಿಡಿಯನ್ಸ್ ಅಲ್ಗಾರಿದಮ್ ಯೂಸ್ ಮಾಡಿ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು? ಅಗೇನ್ ಸೇಮ್ ಪ್ರೊಸೀಜರ್. ಯುಕ್ಲಿಡ್ಸ್ ಅಲ್ಗಾರಿದಮ್ ತಗೊಂಡು ನಾವು GCD ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಿದ್ವಿ. ಸೇಮ್ ವೇಯಲ್ಲಿ GCD ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಲ್ಲಿ ನಮಗೆ GCD 1 ಅಂತ ಬಂದ್ರೆ, now then you can say given two numbers are relatively. We check that with example. Same. Now we'll check. So I'm going to mention here using Euclid's algorithm. Check 33 and 19 are relatively prime or not. Prime or not. Or check whether 83 and 19 are co-primes. So now what is the procedure? First step is to find GCD of 83 and 19. Euclid's algorithm. Using Euclid's algorithm, we have to 19 divides 83. Yes, ಇದೆ ಅಲ್ವಾ Euclid's algorithm. ಏನು Euclid's algorithm rule? First step 83, 19 divides 83. After that, whatever remainder you will get, remainder divides your divisor. Again, second remainder divides your divisor, like this, until then you should get a non-zero remainder, last minimum. So now 19 into 4, 76. What is your remainder? Remainder is 7 here. Yes, ಇದನ್ನು ಯಾವ ಟೈಪ್ ಬರೀಬಹುದು ನಾವು? GCD of 83, 19 can be written as 19. ಏನು ಮಾಡಿದ್ವಿ ಇಲ್ಲಿ? 83 mod 19. 83 mod 19 ಮಾಡಿದಾಗ ರಿಮೈಂಡರ್ ಏನು ಬಂತು ನಿಮಗೆ? GCD 19. 83 mod 19 ಅಂದ್ರೆ ಏನು? 19,7. So next now we need to find GCD of 19,7. GCD of 19,7 is what? GCD of now 7 next to ನಿಮ್ದು ರಿಮೈಂಡರ್ ಡಿವೈಸರ್ ಆಗುತ್ತೆ. So 7 19 mod 7. So ಅದು ಹೇಗೆ ಮಾಡ್ತೀರಾ ಈಗ? Next to we do here 7 divides 19. Yes, 7 into 2 14, remainder is 5. So GCD of 19 and 7 is equal to GCD of 7,5. Next, GCD of 7, 5 can be written as GCD of 7, 7 mod, sorry, 5, that is 5. GCD of 5, 7 mod 5. So this is equal to here. 5 divides 7, 5 into 1, 5. What is the remainder? Remainder is 2. Remainder into 2. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅವಾಗ GCD ಇದನ್ನ ಯಾವ ರೀತಿ ಬರೀತೀರಿ 5, 2. Remainder is 2. Yes. Next to GCD of 5, 2. ಇದೇನಾಗುತ್ತೆ GCD of 2, 5 mod 2. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಿ ಅವಾಗ we divide first. Yes. 2 divides 5. 2000. Yes, 4. What is the remainder? Remainder is 1. ಏನಾಯ್ತು ಅವಾಗ GCD of 2, 1. Next to GCD of 2, 1 is equal to GCD of 1, 2 mod 1. ಏನಿದು 1 divides 2, 1 into 2, 2. So you have got 0 as remainder. So then previous one, the non-zero remainder is this. Right? That is your GCD. So what it is? GCD of 1, 0. What it implies? So therefore it implies, therefore GCD of 83, 19 is what now? This one. This is our GCD. So is equal to 1. So once you have got GCD as 1, so GCD as 1, what it indicates? Since GCD is 1, you can say hence 83 and 19 are what? They are relatively prime. They are relatively prime numbers, or you can say they are co-prime. This is how to check whether given numbers are relatively prime or not. Right? So now, next we can check these numbers. The numbers to be relatively prime, or the two numbers are said to be relatively prime or co-primes, whether it is compulsory that A and B are prime numbers or prime or composite or two composite numbers, we'll check with the examples. We'll check those various scenarios for two numbers to be co-prime. Yes, we'll check. Consider for that what I am going to check here. I am checking various scenarios for two numbers. Explaining this with example to be co-prime. Relatively prime. ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಲ್ಲಿ ಅಂದ್ರೆ ಎರಡು ನಂಬರ್ಸ್ co-prime ಇರಬೇಕು ಅಥವಾ ರಿಲೇಟಿವ್ಲಿ ಪ್ರೈಮ್ ಇರಬೇಕು ಅಂತಂದ್ರೆ ಅವು ಯಾವ ರೀತಿಯಾದಂತ ನಂಬರ್ಸ್ ಇರಬೇಕು ಅನ್ನೋದನ್ನ ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇರ್ಬೇಕಾ, ಯಾವ್ದು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡ್ಬೇಕಾ, ಯಾವ ಟೈಪ್ ನಂಬರ್ಸ್ ಇರಲೇಬೇಕು ಅನ್ನೋದೇನಾದ್ರೂ ಇದೆಯಾ ಅನ್ನೋದನ್ನ ನಾವು ಚೆಕ್ ಮಾಡೋಣ ಈಗ. ಸೊ ಫಾರ್ ದಟ್ A, this is one number B. ಏನ್ ಕಂಡೀಷನ್ ಇದೆ ನಮ್ದು? Two numbers are said to be relatively prime if their GCD is 1. This is the only first condition. GCD 1 ಇರಬೇಕು. Relatively prime or what? Our question. Yes, relatively prime. Next, we'll write remark. Remark is what? It is about the numbers A and B. Yes. Let us consider first one. we'll take two numbers 11 and 17. Yes. Both 11 and 17 are what? 11 and 17 are prime numbers. Yes. Since they are prime numbers, what are the GCD? They don't have any common factors. GCD is 1. Since GCD was 1, of course, they are relatively prime. Yes. What is the remark here? Both A and B are primes. Yeah. Next is, we'll take another example. From saying this, can you say for two numbers said to be relatively prime, is this compulsory that should be prime numbers? We'll check by taking composite number. We'll keep A as 11 only. We'll take one composite number. Let us take 21. Yes. So 21, 11 divided, it has a divisor 1 and 11 only. It's a prime. No, 21. What are the 21 divisors? Common divisors of 21 are 1, 3, 7 and 21. Right? It's a composite number. Now, among these two, one is common. Yes, only the GCD is 1. Therefore, since it satisfies our condition that GCD to be 1, we can say these two are two primes. It is not compulsorily that both the numbers must be prime only, because here it is a prime number and it is a composite number. Yes, A is prime. Remark, we can write A is prime and B is composite. Yes, now from this what we have seen, ಇದರಿಂದ ಏನು ಗೊತ್ತಾಯ್ತು, ಎರಡು ನಂಬರ್ಸ್ ಕಂಪಲ್ಸರಿಲಿ ಪ್ರೈಮೇ ಇರಬೇಕಂತ ಏನಿಲ್ಲ. ಒಂದು ಪ್ರೈಮು ಒಂದು ಕಂಪೋಸಿಟು ಇರ್ಬೋದು, ಎರಡು ಪ್ರೈಮ್ಸು ಇರ್ಬೋದು. ನಾವು ಕೆನ್ ಸಿ ಎರಡು ಪ್ರೈಮ್ ಇರ್ಬೋದು ಅಥವಾ ಒಂದು ಪ್ರೈಮು ಒಂದು ಕಂಪೋಸಿಟ್ ಕಂಪಲ್ಸರಿ ಇರಲೇಬೇಕಾ? ನೆಕ್ಸ್ಟ್ ವಿ ಟೇಕ್ 12 and 17 ಆ ಕ್ವಶನ್ನಿಗೆ, ಸಾರಿ 77. ಎಸ್, ವಿ ಟೇಕ್ ದೀಸ್ ಟು. ನೌ both are 12 is divided by 1, 2, 3, 4, 6. Yes. Now 12, 77. 77 is divided by 1, 11 and 77. Yes. But the common divisor of these two is 1 only. Both are composite. Yes. Both are composite. Yet they are co-primes. Yet they are relatively prime. So A is composite. Both A and B are, we'll write both A and B are composite numbers. So from this, what you can observe now, ಇದರಿಂದ ಏನು ಗೊತ್ತಾಯ್ತು, only rule is what, only rule to say two numbers are co-primes, are relatively prime, is what, is what, is their GCD must be equal to 1. Only is what, only condition is this. That is no matter about the nature of the numbers A and B. Yes, we have to look into only their GCD. That this condition should be satisfied. Then only you can say two numbers relatively prime. Yes. So from this, what we have understood now? You have understood why we need to find GCD and what are the condition for numbers to be relatively prime or co-prime. That's why. Now, if you want, you can check, practice or check with the example, especially that Euclid's algorithm. Find the GCD of 790 and 121 using Euclid's algorithm. This and determine whether they are relatively prime, whether they are relatively prime or not. ಸೇಮ್ ಪ್ರೀವಿಯಸ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ರೀತಿ ಇದೊಂದು ಎಕ್ಸಾಂಪಲ್ನ ಟ್ರೈ ಮಾಡ್ರಿ. GCD of 719, 121 and check whether these two are relatively prime or not. Comment your answer in the comment box. We'll check that. In the next class, we'll discuss the congruences. That is the beginning topic of your modular arithmetic. We'll start with the congruences. Till then, take care.